want to shout out to the lamest cool kid for following. I don't know if I did that last time, but definitely want to take care of that this time. So thank you, lamest cool kid. Alright, so that's up and ready. We are here. But I want to add a band before I start. So what band do I want to add today? What's something that you have maybe not heard? Oh, you know, maybe that's who I should give them to. So I went and saw these guys. When I posted my video of Sevendust, a band called Nunpoint opened for them. Yeah, this is a great song. I've got it. Good jam. All right, so we were talking about probability in geometry class, and so we have simple probability, and we started with desired outcome over total outcome, where we made the desired outcome our A value. And we did when these were overlapping because we want the probability that it's a female or prefers chocolate. So how many females are there? How many prefer chocolate? We're going to add these two values together, but we count them twice. So we want to get rid of one of those counts. Because if we talk about preferred chocolate, there's 18 and 15. That makes our 33. If we talk about females, there's 15, 5, and 2. That makes up 22. But do you notice how we counted 15 twice? One that's the preferred chocolate row and then the female column. So we don't want to count it twice in our probability because the top number needs to be smaller than the bottom number. So in order for that to happen, we definitely have to take out the double. So we're going to do 33 plus 22, but we need to subtract the overlapping event, which is being female or, well, females that prefer chocolate. Because like I said, you don't want to count them twice. So we did 22 plus 33 minus 15 and got our 40. Out of the total outcome is on our table. You could look at prefers chocolate, prefers vanilla, or no preference. All those will be 50. Or you could just talk about males and females. Those add up to give you 50 as well. So that's how all this chart kind of gets put together. And then when we put the probability together, because we wanted female or prefers chocolate, we did 40 over 50, which simplifies to 4 over 5. So that was our simple probability that we started with. So now what I'm doing is I'm trying to look for review problems, like something I can use for my review. Like looking at this, what's the probability I could pull a queen out of these cards? Well, how many queens are there? How many cards are there? Pulling out an even or an odd number, or you could pull out a color. What's the probability of a red out of all of them? So we would count the number of reds out of the total, count the number of blues out of the total, the greens. So there's a lot of different things you can do with these, even though they're just numbers and colors. I really like this one. I would probably do this. And what's the probability of pulling what? A number less than 10. So what is that? 1, 2, 3, 4, 5, 6, 7, 8. 4, 8. Trying to get away from a number less than. No, gonna do green numbers. Green numbers would be simplified. I could do that, I guess. What's the probability of getting a green number? Okay, so what we're going to do is we're going to, let's see, in our shared drive, I've got my lessons, my performance, which is what I'm going to start trying to fix because I want to do some performance. So this is going to be my review package. So we'll start with 7.1, which is just simple probability. And I can't spell, but I'm also not looking. All right, so we'll steal this picture right here. And go to review packet, post it here. And what is the probability you land on a bubble space? Use justification. There we go. And next, insert horizontal line. There we go. Okay, so so we did a spinner. Ooh. Well, that's pretty interesting. I like that. We can steal this picture. And all simple probabilities. Which color balls most likely to be drawn at random? Ugh. What's the probability of picking the orange ball? What's the probability of selecting a soccer ball? What's the probability of drawing an orange and purple? And what is the probability of drawing orange or purple ball? Okay, so let's do that. Is the probability of drawing orange or purple ball. And purple ball. Sure. And copy and paste that. Copy. Oops. Paste that. Okay. Insert horizontal line. Okay. What else can we do? Is simple probability. We're going to do this and try that again. I'm trying not to pull that thing in the corner. There we go. Okay, so and this. Table thing. Set A. Everything in B. And B. Or B. All right. Okay, so let's talk about this one real quick. I think this is a good question to have in your brain. Let's insert a horizontal line. So when we talk about sets and probability, we're looking at what is in set A. So everything that is involved everything that is involved in A specifically. So when I color in A, what is in A? Well, we can see that B and C are in our A circle. Okay, so that's how we would label this. We would say B and C and then close it up. Then they want to do the same thing, only this time with B. So I would color in B here and say, oh, there is C, D, and E in set B. Okay, now this one, when we do A and B, okay, so what we're looking for in A and B is we are looking for that one that is squeezed in both of them. Okay, so when we do that, A and B, the only thing that's in A and B is C. Now, if we do the opposite and we do A or B, now we're talking about everything, like everything over here, everything that's in between, and everything that's over here. So now we would label all of these B, C, D, and E. All right, and then the last one's asking us about our universe. And our universe is usually, more oftentimes than not, there's a box around it, and there's a U in the corner. Or you just need to know that all the points on here belong to our universe. So now we will label everything that we see. That is what our universe entails. So when we look at this, and this is a set notation, but understanding where this A idea comes from, especially when we do like the desired over total, going back to 7.1 when we did this or we talked about this, the probability of A is desired outcome over total outcome. I did a crappy job for 7.1. For 2, I did much better. We're looking for the number of A's over the number of total outcomes there are. So we defined A as desired outcome. For this problem specifically, it was having a savings account but not a job. And then the total T was any person on the table. So the probability of A happening was the number of A outcomes, which is has a savings account but not a job. So, and then the number of T's. So how many people have a savings account but do not have a job? And we would see right here that there are 66 people that have a savings account. They're in the yes, but have a job. They are in the no's. And then our total, we go to the grand total because it's not a conditional probability. No conditions are put on it. It's just saying what is the probability that a person, and then goes into has a savings account but not a job. Now, if it said what is the probability that a person who does not have a savings account, and start to put a condition on it, that's a whole different probability. So we're drawing a person that does not have a savings account but has a job. And when we look at does not have a savings account, we're only looking at the people that do not have a savings account. So there'll only be 100 people. And have a job, there are 16 over 100 because we're putting a condition on it. Okay. So, let's look at that. Look at that real quick. Go over here. Nothing. Any questions? No. Just making sure we're still clean. And steps to probability, formula in words, assign A in words, assign T in words. The formula with N of A and N of T, assign what N of A is with a number, assign what N of T is with a number, and then substitute and simplify. Those are your steps. So in our review packet, we have to know what these sets are in order to be successful into actually calculating probability. So that looks good for 7.1. Now, moving on to 7.2, that is two-way tables, probability with two-way tables. So we want to do probability and go two-way tables. Okay, and then they have a plethora of two-way tables. And what we'll do is we'll borrow a two-way table. Interesting. Hypertension diagnosis, smoker, non-smoker. That's a tasty one. Well, education with it. Let's insert page break. Let's say 7.2 two-way table probability. Insert table. And we want to insert a table that is 2, 3 total. 1, 2, 3. Okay. So, so we have okay. We have oh my goodness, non-smoker. And then we are going to do total. And we're going to have them fill it in. Hypertension. Oh. Tension. Start by completely. Huh. Should I? Almost curious. Let's go with what is the probability that a person is diagnosed with hypertension and is a non-smoker. Use justification to insert horizontal line. Okay, that looks good. So what they would do is start filling in this table. So let's go ahead and show that so that we're demonstrating some math right along with it. So we will put 48 here, 26 here, and then we're going to add both of these together, and that's what's going to go here. So 74, and then we have 24 and 50, which makes 74. Now if we were to add them across here, 60, what is that, 72 and 76, and now if we add these across or straight up and down, either way we should come up with the same solution of 148. Now, using our two-way table, we want the probability of something happening, and that is desired over total, and our desired is that they are hyper and a non-smoker over the total. So when we look at this, there's no condition put on it, or just the probability that a person. So our total is going to be 148. And then we're looking for a hypertensional diagnosis. And then we are looking for a non-smoker. So when we go with that, the intersection of those two, because it's an and, not an or, we are going to come up with 26 out of 148. And then we could simplify that. Oh, you can put it in the calculator and simplify it that way. You can divide the top and bottom by 2 until you can't, then try 3 until you can't, and keep going on that process as far as you can go. Like when I do 2, I'm going to get 13 on top, and I'm going to get 74 on the bottom. Then the only thing left, because 13 is a prime number, is divided by 13. And if we do that, the only number that would work would be 24 to get the 4 in the one spot. So that would be 8. So 8. And 8 becomes too big. Okay. Yep. So that's going to be our simplest form. Yeah, I think that's a good problem. I almost thought about maybe making them fill this in as well. But I don't know. I think taking it one step at a time and trying to get them there. Otherwise, I might over confuse them. Maybe I make them do it on the test or performance. I don't know. I'd like for them to know what the table, where the table comes from, and how it's put together. I do think that's important. All right, two-way tables. Back to two ways. Ooh. Like this table for sure. Okay. Drop that. There we go. What is the probability that a person has a math background or a chemical background? Use justification to support your answer. So, back to probability. Once again, desired over total. Now, this one's an or. So, once again, we have an overlap with math and chemical because the math is 85, 80, and 89. the chemical is 80, 91. And if we see that, maybe highlighting it, you'll see it. Because 80 and 91 make up the 171. 85, 80, and 89 make up the 254. So do you see how 80 gets counted twice, how it's dark overlapped? That's because you counted in the math and you counted in the chemical. So when it's double counted, we don't want to double count it. We only want to single count it. So we want to subtract that intersection of the two. So when we do this, we're going to do this plus that and then subtract the intersection of them so that we don't get that overlapping. But yeah, another good two-way table problem. I like that. That's a good one. Oops. Don't do that. Okay, let's skip that. Let's get off here. Okay, now insert horizontal line and go back to two ways. Debate film. Ooh. Okay, so let's go here. We are going to do a 4 by 4. That's a table. It's the dimension to of the table. All right. So we would start with male, female, total. We would do long, short, and then total. So 30 rabbits are male, 8 female. Oh, 30 rabbits are male. Oops. 8 of the female rabbits have short hair, and then 12 of the rabbits with long hair are male. So then that means 18. Then that would mean 26. Am I missing? Am I missing? 45 total. Okay. Oops. Let's do this. I missed. Emma has 45 rabbits. So now, there we go. Okay, so let's mop that up for a second. So then we would do male, female, total, short, long, and we know there's 45 here. 30 male rabbits, so that makes 15 female rabbits, 8 of the female rabbits have short hair, which means 7 of them have long hair. 12, and then 18. Remember that made, this makes 19. This made 26. And that should be 45 and 45, which it is. Then we're going to do the probability that, what's the probability that a rabbit has long hair? Which would be 19 over 45. Is what is the probability that a rabbit has long? All right, I like that one. And that would be 19 over 45. Use specification to work answer, of course. Good. So that gets us out of 7.2. 1, 2, 3. Okay. And now, insert page break, and then we're gonna go 7.3 additional. Not bad, not bad. That and go conditional probability. Yep. A lot of crazy. Yikes, yikes, yikes. Let's go with this. Guess we should put a deck of cards on there. Can do a card problem for sure. What is the probability that a red card is also a check? One, okay. Okay. So what we would do is we would count out the number of red cards and then we would do the number of jacks. And how we did it was B is the conditional outcome. So we want it to be a red card. And then the desired outcome is kind of A and B. It's a red card, but what about that red card is that we want it to be a jack. And there were 2 jacks out of all the red cards, which there are 13 of each suit, so I'd make a total of 26 cards. All right. Use application to support. Okay, so let's go here. And we will copy this. Paste it here. Now, what is the probability that a person with a math background also has a chemical background? Probability of drawing a person with a chemical background given that they already have a math background. Okay. Question in 2 different ways. Let's make sure that they understand that. Insert horizontal line. Stickler for stuff like that, and did put a space in between it last time. Okay. Because a coin is tossed 2 times. Heads, head, tails, head, tail, tails. 2 heads. Kind of like that one. Right now, I'm just looking for some probability problems. We're putting together a review packet for geometry we started with simple probability with sets and set notations, like what is in the set of A, set of B, A and B together, or A or B, so it could be in it, or the universe, which is all of it. I saw some viewers jumped in, so I'm just kind of giving a quick synopsis. For this one, looking at a spinner, we could have used odds, evens, colors, greater than 10, less than 10, and really come up with some different probability questions. The one I liked because it could be simplified, and I'm really kind of focused on simple probability for this, is what's the probability to land on a purple space? So really kind of getting into the desired over the total, telling us what the desired is in words, telling us what the total is in words, then giving us the number. And I didn't do a great job in this one. I did a much better job in 7.2 where I said n of a, like what's the number of a's, what's the number of total, and then doing the probability of a over the total, substituting it in and then simplifying it. So for this problem, what's the probability you do purple? Well, there are 2 purple spaces out of 8 total spaces. So then we would have, when we did this, done 2 purple spaces and then 8 total spaces, done 2 over 8 for substitution, and then we could simplify that into 1 over 4 would be our simplification for that process. But really just having to practice through. Which color ball is most likely to be drawn at random? So having an idea that you see 3 soccer balls have more chance of being drawn. So I'm just going to test their knowledge and see if they can get this. And then really kind of getting into the root of what's the probability of drawing an orange or a purple. So how many orange are there? How many purple are there? So that would be 4 out of my total. 1, 2, 3, 4, 5, 6, 7, 8. 4 out of 8, which simplifies to 1/2. And then this question hopefully will trip them up a little bit, but once they start to think about it, what's the probability of drawing an orange and a purple ball? So only one of these is orange and purple. And hopefully they're going to tell me nothing, because there are no balls that are orange and purple. We'll see how that one goes. All right, then we have our two-way probability. So filling in tables, coming up with that, having a table given to us, and then kind of completely scratch. I guess what I should do, I should X this out and put it there. I should do that problem first, and then this one, and then that one. All right, then lastly, conditional probability. I don't know. I don't really, not really feeling any of the other ones for probability. All right. I think I am gonna call it. No, I don't like it. I just wanted a heads and a tails, and then a heads tails, and then a tails heads and a tails tails. That's all I really wanted, but I don't have one of those without the one halves on them. I don't want the one. Ooh, maybe I do. Maybe I do. Okay. Maybe I do. All right. Let's see this. Flipping a coin. If we flip a coin twice, you will see the outcomes. H point heads, T equal tails. Is the ability that you get a tails given you through you flipped a heads first. What is the probability that you get a tails given that you flipped a head first? What is the probability that you flip a head then flip a tails? Same question, two different ways. That's that. And then use justification. That. Paste that. Okay, so we have the review packet done for geometry. All right, and that's conditional probability. Well, if you came and hung out, thanks. If you stopped in, great. As of today, I don't really think I have anything else really to share. So I think I'm going to call it on that one. If you have any questions or comments, please let me show this real quick. Pop in the Discord, throw it in the questions, and I will definitely bring it up and answer it no matter what. You can see that the live stream's up and running quite well. The schedule's right here, Mondays and Wednesdays. I'm live from 8 to 9. You're free, ask any questions you want. I was doing private sessions when needed. So yeah, feel free. I've got set up for private sessions. You won't see that. But check out the bands. The one I posted at the beginning, Animals. I gotta post Kippy and Clover, but I've got an axolotl and a cat. But I don't take too many pictures of my animals. I take plenty of my kids. Food, some random food. I'm a foodie for sure. I need to post more food. I definitely have. I don't know. I don't take pictures of food, but I cook every day. So I'm a fan of cooking. Social media. If you get into this, or someone that is looking at a YouTube video or something, when you come here, there are rules, and you can see there are actually three people that haven't even reacted to the rules, and you can't see anything else until you do. I want to make sure that these rules are read, understood. It's just important to me, like you got to keep it clean in this chat. If I'm having students come in either from my school or from other schools, I want them to feel like it's a safe place for them. And then they need to come and do roles, and they're either going to be a student or a parent. All are welcome. If you thinking about becoming a tutor to help out, start as a student, and we can move on from there. And yeah. So, any questions, feel free. Like I said, hit me up. The questions, I really would love to answer questions and take time during this instead of, I mean, I always do stuff for my class and for my students, but I really am trying to build a community who needs math help. So, if you want, ask a question and I guarantee it will be answered in the next stream. So, yeah, have a wonderful night and until next time, keep mathing. Throw this back over here. That's that. And